Welcome to Reality Creative Video. I'm Hermes, and today we're going to talk about the backbone of the electrolysis process, the power supply. Nothing would happen without the power supply. Now, for most of you, you're probably using one of these brick-type power supplies. They come in various voltages, anywhere from 20 to 36 volts, 38 volts. I even hear some people are cooking gold with the smaller 5-volt supplies, which I find that really hard to believe, but hey, anything is possible. For my work here, I use a heavy-duty Wanptek 0 to 60 volt 5 amp max power supply. It supplies pretty much everything I need to cook my colloidals. Now, the power supply has the voltage and current. Now, colloidals, for the most part, cook with current. But you can't have current without voltage. And so, while a power supply might have a lot of current, it may not have enough voltage. And the reverse is true too. While a power supply may have a lot of voltage, it may not have enough current. So it's important to have a power supply that can handle your colloidal electrolysis needs. Now for me in the lab here, this serves my needs very nicely. Now I'm cooking, you can't see it, but down here I'm cooking colloidal platinum. And one of the things that's important when I'm cooking colloidal platinum, or other colloidals as well, is current. Colloidal platinum has to have the current locked. So what this power supply has, besides being able to set a specific voltage, like here, right now we're dishing out 40.85 volts, but we also need to be able to set a specific current. Now with platinum, I need to set a specific current. I got 1.502 amps, or 1500 milliamps. I have it locked in at 1502 milliamps, 1500 milliamps. And to deliver that 1500 milliamps, the power supply is putting out roughly 41 volts to do that. And the voltage in this mode might vary up and down in order to maintain the current. Now, if I was in voltage mode, the current would vary and the voltage would stay the same. It depends on the colloidal you're cooking and how you want to cook it, to be honest with you, on what mode you're going to have the power supply in. Now, colloidal gold requires about 250 milliamps, quite small, a lot smaller than here, to cook it. And I will cook colloidal gold at 37.5 volts. I pretty much don't current limit colloidal gold, but I certainly could current limit it to 250 milliamps, but I don't. It takes about 30 minutes. You can do it either way with gold. You could limit your current to 250 milliamps, and then you'd get about 35 or 35 volts coming out of it. If you have this kind of a supply. If you have one of these bricks, you're out of luck because you're at the mercy of whatever the power supply can put out, the current it could deliver, and the voltage it can deliver. So, I mean, your colloidals may work or they may not work. That's why, for me, having a variable power supply is extremely important so that I can get consistency with my colloidals. So this is a pretty high current colloidal platinum that I'm cooking right now, and I just want to show you. If I turn these two knobs up here are for adjusting the voltage. You have a coarse adjust and a fine adjust, and this two knobs down here is for adjusting the current. You have a coarse and a fine. So right now I have it locked to 1502, so I can raise this up if I want to. All right, and you can see the voltage is going to jump up at the same time. All right. The maximum this can put out is 60 volts, but now we've switched to constant voltage because we've reached the maximum current that this solution can draw, which is 2 2,167 milliamps. Now that's a little bit too high for this particular colloidal because it cooks it too fast and it gives me too much platinum dioxide on the metal. So I have to cut it back. It takes longer to cook at a lower current, but it gives me less, in the case of platinum, gives me less platinum dioxide that I have to deal with, which affects the taste and also is a really pain in the neck to remove. Now, some colloidals don't produce dioxide. Gold doesn't produce any noticeable dioxide. Zinc copper will produce heavy dioxide if you're not careful. And figuring out the current can help with that stuff too. You want to cook a colloidal at a reasonable current. You don't want to cook it too fast. You don't want to cook it too slow. And like I said, it all depends on the colloidal that you're cooking, which is why a variable power supply is absolutely needed. So, as you can see, I've returned this back to 1.5 amps or 1500 milliamps, and it's back on the CC, the red light's lit, which means it's now back doing the current. Now, some colloidals, this is using 1500 milliamps, but other colloidals use very little, like colloidal silver will start at 240 microamps, 0.24 milliamps. Now, this meter here is unable to do sizes that's amperage that small. So what I have here in the back, if you see it here, I'll bring it a little closer. I have a handheld multimeter, and it's got a 20 milliamp scale and a 200 milliamp scale. And I will use this with, I got leads here. See these leads? All right. They will go in series. I can switch them around. Like right now, because this can't handle 1500 milliamps. You'll blow this meter out. So you'll need both. You'll need one of these power supplies that have the reading, the digits on there, the current, the voltage, and you'll need one of these. Now, whatever way you decide you want to cook your colloidals, either by limiting your current or setting a set voltage, consistency is the most important part of the whole process. Unless you're cooking a colloidal that you have to do one or the other. Like in the case of platinum here, I don't have much choice. It's going to cook too fast that if I unclamp the voltage. So, power supply is important, guys. And if you're serious about colloidals, then you want to get a better power supply. Because it'll make your life a hell of a lot easier. Now, in gold, I tried to, in the beginning days, before I had this power supply, I tried to cook gold with one of these bricks. Gold takes, like I said, about 250 milliamps. I nuked the power supply. It was gone. It couldn't handle the heat and the voltage and the current. Even though it was rated at 500 milliamps, it fried anyway. So, those bricks aren't the best choice for your colloidal, electrical usage if you're serious about colloidals. So, get into some serious colloidals, platinum and gold. You need a better power supply, especially if you want to get ruby red colloidal gold every time out of the gate. So, not that the power supply has anything to do with the condition of the colloidal you get. That has other factors. But what I'm saying is it makes life a lot easier. You have the voltage and the current necessary to actually cook colloidal gold in a reasonable amount of time. All right, well, that is my discussion on power supplies for colloidal use. I hope you found it interesting. You have any questions, please leave some comments behind, and I will get back to you on it. I will I will be continuing this series with my other lab equipment, one at a time, and demonstrate to you how I use these equipments in making my colloidals.